welcome back to my online teaching platform. We are still looking at applications of differentiation, all right? But in this video, we'll consider application of differentiation in relation to small changes, small changes. So I have a video on the introductory part of small changes. So we have to now learn how to apply what we learned under the introductory part of small changes. All right. Now we have our first problem here, and we have to find a solution to it. And the question is, find the approximate increase in the area. It should be in the area. Okay. So let me correct it. In the area. In the area of a circle. All right. Should be in the area of a circle. If the radius is increased from 3 centimeters to 3.01 centimeters. So it means the radius has been increased from 3 to 3.01 centimeters. So the increment is very small. That is why we consider this concept to be small change or small changes. We are focusing on how to determine a small change as a result of a small change in one or the other quantity. So when you have the area of a circle, the formula for finding area has two variables, one being the dependent and the other one being the independent. So the area always depends on the radius. So the radius is the independent and the area is the dependent variable. So in this case, the radius of the circle has been increased from 3 to 3.01, which simply means that the area too will increase. Okay, so we want to know the amount of increment. All right. The amount of what increment when it comes to the area. Okay, the moment it has been the radius has been increased, the area too will increase. So we want to know how much the area has what also increased. So that's what we are looking at. So let us start with, we have our solution here. Okay, so the initial radius is this, is 3 centimeters. Okay, let me use this one, R0, and it has increased from 3 centimeters to, this is the final radius, all right, R1 to 3.01 centimeters. Okay, so let us determine the increment, the small increment. So that will be our R1 minus our R0, that is R0. That will give us 3.01, 3.01 minus 3.00, which is the same as the 3. We are going to get a result of 0.01, okay, centimeters. So this is the increment that has, the small increment that has occurred in the radius of the circle. Now we are to find its corresponding change, okay, the corresponding increment in the area. All right, so let us look at how best we can do it based on what we did in our first video. Let us look at how best we can answer this question. So bring our formula for finding area of a circle, because the focus is on area of a circle. So area of a circle, which is A, is equal to pi r squared. All right, pi multiplying r squared, where r is the initial radius. So we need to differentiate the area with respect to the radius. So we are going to get it as 2 pi r. Okay, and we can now substitute the radius into the given derivative. So we have it to be 2 pi. So we can say that, but our R, which is it should be the R naught. Use the R0, that's the initial radius, okay, which is 3 centimeters. Okay, so we are going to get here to be 3 centimeters, and this will give us a result of 6 pi. Okay, so our dA/dr is equal to 6 pi. Now we know that when it comes to small change, our dA/dr, is approximately the same as, or is approximately equal to, or the same as small change in the area, okay, with respect to a small change in the radius. Okay, now we know the our dA/dr to be 6 pi. Okay, so we are going to replace it with 6 pi equal to small change in A, which is the area, divided by the small change in what? Radius. So we know our small change in radius to be our 0.01, which is here. All right, this is a small change. The difference between the two radii will give us a small change. So we have it as 0.06 over here. Then we cross multiply, because 6 pi is the same as 6 pi divided by 1. So here we are going to get it as 6 pi times 0.06 equal to small change in what? A. And here we are going to get 0. Oh, sorry, here is 0.1. So we are going to get it to be 0.06 pi. All right, and this will be the corresponding small change in the area when the radius increases from 3 to 3.01. Therefore, the approximate change, the approximate change in the area is equal to 0.06 0.06 pi. All right. Thank you for watching. We'll be answering more questions on this, right? So that we'll be able to get a solution to any problem in relation to small changes. Okay. So anytime you have a problem, try to determine the small change. Then the next thing is you have to identify what the problem is talking about. Okay, here the focus is on area of a circle. So you have to now state the area of a circle. Then you differentiate the function with respect to the independent variable. Okay, and that must be equal to, so if we have the area, it means you are differentiating the area with respect to the radius. Because you want to find a change in the area as a result of what? A change in the radius. And this is approximately the same as the small change in area divided by the small change in what? The radius. So that's what we have here. This is the formula that we had over here. Right, then you just substitute the various components. You have your dA/dr, meaning you are going to differentiate the area with respect to r. Then you plug in the initial area, sorry, the initial radius of the circle. Then you are going to get your dA/dr. When you are done with that, you substitute that value for dA/dr, and everything equal to small change in A, which is the area divided by the small change in radius. We know the small change in radius to be the final radius minus the initial radius, which is 3.01 minus 3.00, and we had it to be 0.01. So in place of the small change in the radius, we are going to put 0.01 there. All right, then you make the small change in the area, which is the A, the subject, and that will give you the approximate change in the area when the radius increases from 3 to 3.01. Thank you for watching. Please do not forget to subscribe to my YouTube channel and equally share my videos with others to subscribe to my channel.